What if I told you that human beings have built machines so gigantic they can literally be seen from space? And at the same time, machines so impossibly small they can swim inside your bloodstream and you'd never even feel them. We live in an era where engineering has pushed itself to two completely opposite extremes, and both ends of that spectrum are absolutely mind-blowing. On one side, you have mechanical monsters that weigh millions of pounds, stretch longer than skyscrapers laid on their side, and move enough Earth in a single day to fill dozens of Olympic swimming pools. On the other side, you have invisible machines built from just a handful of atoms, so tiny that 50,000 of them could sit side by side across the width of a single strand of human hair. These aren't science fiction. These machines exist right now, on this planet, built by real engineers and scientists who refuse to believe in limits. Today, we're going to explore both worlds, the biggest and the smallest machines ever created by human hands. Get ready, because what you're about to hear is going to completely change how you see the scale of what's possible. Let's start big, really, really big.
Number 5 on our biggest machines list is the Prelude FLNG. And this thing isn't just a machine, it's basically a floating city. Built by Royal Dutch Shell, along with partners Kogos and Inpex, and constructed in South Korea, the Prelude was completed in 2013 at an estimated cost of around $12.6 billion. Its full name is the Prelude Floating Liquefied Natural Gas Facility, and that tells you exactly what it does. It sits out in the open ocean and extracts, processes, and stores natural gas right there on the water. The numbers are staggering. It is 488 meters long and 74 meters wide. Fully loaded, it displaces around 600,000 tons of water. That's more than 5 times the displacement of a Nimitz-class aircraft carrier, one of the largest warships ever built. It is permanently anchored about 475 kilometers off the northwest coast of Australia and is designed to stay in place and operate for at least 25 years without ever returning to port. To put its size in context, if you stood the Prelude on its end, it would be taller than the Empire State Building by 45 meters. This is not a ship. This is a floating industrial continent.
Number 4 is Big Bertha, the largest Earth pressure balance tunnel boring machine ever built. Bertha was manufactured by Hitachi Zosen at their Sakai Works facility in Osaka, Japan, and was assembled on site in Seattle, Washington in 2013. She was built specifically for the Washington State Department of Transportation's Alaskan Way Viaduct Replacement Tunnel project, designed to dig a 2-mile tunnel directly beneath downtown Seattle. Her cutting head alone is 17.5 meters in diameter, about 57 feet across. Her full length stretches 300 feet, and she weighs approximately 7,000 tons. Bertha had 600 cutting discs mounted on her steel face, ran on 22,000 kilowatts of installed power, and could generate a maximum thrust force of 392,000 kilonewtons. She cost $80 million. The project hit major trouble in December 2013 when Bertha struck an abandoned steel pipe that had been forgotten in the ground, damaging her cutter blades and putting her out of commission for 2 full years. After an extraordinary recovery operation where engineers dug a 120-foot-deep rescue pit to reach her, Bertha was repaired and finally completed the tunnel in 2017. She was then disassembled and shipped to new work sites around the world.
Number 3 is the F-60, known as the Horizontal Eiffel Tower of Lusatia. This is the longest movable machine ever built on land. The F-60 was constructed by VEB Tackraft Lauchhammer in Lichterfeld, Germany, and was built between 1989 and 1991. It is a conveyor bridge, an enormous overburden transport machine used in open-pit coal mining to move waste material called overburden away from the mining area. There are 5 of these machines in existence. The F-60 stretches 502 meters in length, 182 meters longer than the Eiffel Tower is tall. Its width is 204 meters, and its height is approximately 80 meters. Even after modification and some disassembly of components, it weighs around 11,000 tons. To give you a sense of scale, it is essentially a movable steel bridge nearly as wide as it is tall, crawling across the Earth on a track system.
One of these machines operated at its site from March 1991 to June 1992. Today, some of the F-60 machines have been preserved and turned into extraordinary industrial monuments that you can actually visit in Germany. Number 2 is the Bagger 293, officially designated the MAN Tachraf RB293. And this is the largest land vehicle on Earth, certified by the Guinness World Records as the tallest terrestrial vehicle ever built. It was manufactured by Tachraf, based in Leipzig, Germany, and completed in 1995. The Bagger 293 is a giant bucket wheel excavator designed for large-scale open-pit lignite coal mining in the Hambach mine in western Germany. It stands 96 meters tall. That's about 315 feet, roughly equivalent to a 30-story building. Its length is 225 meters, or 738 feet. It weighs an almost unbelievable 14,061 metric tons, which is over 31 million pounds. At its business end, a massive rotating wheel 71 feet across is fitted with 18 buckets, each capable of holding around 1,452 gallons of material. That wheel scoops up earth and dumps it onto a conveyor belt system that carries it away continuously. In a single day, the Bagger 293 can move 8.5 million cubic feet of earth, enough to dig a hole the length of a football field and 80 feet deep. It requires a crew of 5 people to operate, and when it first needed to travel from the factory to its first mining site, a distance of just 80 miles, it took 3 full weeks to get there. And number 1, the absolute largest machine ever built by human beings is the Large Hadron Collider, or LHC, operated by CERN, the European Organization for Nuclear Research. This machine is in a category completely by itself. The LHC is a particle accelerator built inside a circular tunnel that runs 27 kilometers, about 17 miles, in circumference, buried 175 meters underground beneath the border of Switzerland and France, near the city of Geneva. The tunnel itself, called the LEP Tunnel, was completed in 1988. The full LHC machine was decades in the making, requiring the work of thousands of scientists, engineers, and technicians from over 100 countries. It officially fired its first particle beam on September 10, 2008. The machine accelerates protons to nearly the speed of light in 2 beams traveling in opposite directions and then smashes them together so scientists can study the subatomic particles produced. This is the machine that confirmed the existence of the Higgs boson particle in 2012, one of the most significant discoveries in the history of physics. The LHC cost approximately 4.75 billion Swiss francs to build. And here's the beautiful irony. The largest machine ever built exists for one purpose only: to understand the very smallest things in the universe. Now, let's flip the script completely. Welcome to the world of the impossibly tiny. Number 5 on our smallest machines list is the IBM 2-nanometer chip. In May 2021, at IBM's research lab in Albany, New York, the company announced a breakthrough that stunned the entire semiconductor industry: a working chip built on a 2-nanometer process. To understand how small that is, 1 nanometer is 1 billionth of a meter. The transistors on this chip are roughly the size of 2 DNA strands placed side by side. IBM packed 50 billion of these transistors onto a chip roughly the size of a human fingernail. For comparison, a 7-nanometer chip, which was considered cutting edge just a couple of years before, fits about 30 billion transistors. The 2-nanometer chip was projected to deliver up to 45% better performance and 75% less energy consumption compared to that previous generation. IBM said it could quadruple the battery life of a smartphone and dramatically cut the carbon footprint of data centers. Each individual transistor on this chip is so small that if you magnified it to the size of a marble, the chip itself would be over a mile wide. IBM developed this technology at its Albany Nanotech complex in partnership with the state of New York as part of a broader push to lead the global semiconductor race. Number 4 is the RoboBee, the world's smallest flying robot, developed at the Weiss Institute for Biologically Inspired Engineering at Harvard University. The RoboBee project was initiated in 2009 under Professor Robert Wood and his team, and it has gone through numerous iterations since then. This tiny machine is about the size of a human fingernail, weighing only about 80 milligrams, less than a tenth of a gram. It flies by flapping its wings at approximately 120 times per second, mimicking the flight mechanics of a real bee. The wings themselves are made from ultra-thin carbon fiber and polyester film. The RoboBee cannot yet carry its own power source, as any battery heavy enough to power it would ground it immediately, which means it must remain tethered to a thin cable during flight. But in 2019, Harvard researchers demonstrated a version that could wirelessly transition between flying and swimming in water, a remarkable breakthrough. The long-term vision is a swarm of RoboBees that could one day perform artificial pollination as bee populations decline, assist in search and rescue operations, or provide surveillance in areas inaccessible to humans. Number 3 is the Penn and Michigan Microbot, the world's smallest, fully programmable autonomous robot, announced in December 2025 by a joint team from the University of Pennsylvania and the University of Michigan. This machine is absolutely breathtaking in its smallness. Each robot measures approximately 200 by 300 by 50 micrometers, making them smaller than a grain of salt. You could place one on the ridge of a fingerprint and it would be nearly invisible. These robots can swim through liquid, sense their surroundings, respond to that information, and carry out tasks entirely on their own. No external controller required. Their brains are built on a chip less than a millimeter across, developed by Professor David Blau's team at Michigan. They are powered by microscopic solar panels generating around 75 nanowatts, over 100,000 times less power than a smartwatch uses. They can operate for months continuously and cost approximately 1 US cent each to manufacture. The researchers envision these microbots one day swimming through the human bloodstream to monitor individual cells, detect disease, or deliver medicine to precise targets inside the body. Number 2 is Bernard Ferenga's molecular nanocar, one of the most extraordinary machines in human history, and the work that won its creator the Nobel Prize in Chemistry in 2016. Bernard Ferenga is a chemist at the University of Groningen in the Netherlands, and he built what is essentially a functioning four-wheel drive car made entirely from molecules. The nanocar has a molecular chassis and 4 molecular motors that function as wheels. When exposed to light, the molecular motors spin, all in the same direction, propelling the car forward across a surface. The entire vehicle is thousands of times smaller than a strand of human hair. To take a ride in this car, your body would need to be 1,000 times smaller than a human hair. Ferenga's molecular motor was first created in 1999, and by 2011, his team had assembled the full four-wheel drive nanocar. By 2014, the motor had been optimized to spin at 12 million revolutions per second. Ferenga, along with Jean-Pierre Sauvage of the University of Strasbourg and Sir Fraser Stoddart of Northwestern University, shared the Nobel Prize for their combined work on molecular machines. The Nobel Committee described their achievement as taking chemistry to an entirely new dimension. And number 1, the smallest machine we know of is the single-atom motor, first demonstrated at the University of Mainz in Germany. Scientists there created a heat-powered motor from a single vibrating atom trapped inside a nanoscale cone of electromagnetic radiation. Let that sink in. 1 atom. That is the entire machine. The atom is trapped using laser fields and oscillates, expands and contracts in a cycle that works on the same fundamental principle as a car engine. It heats, expands, cools, and contracts. This is not just theoretical. It is a working engine with thermodynamic cycles, built from the smallest possible unit of matter. At the University of Texas at Austin, researchers have also built a nanomotor that is under 1 micrometer in all dimensions, meaning it could fit inside a living human cell and spins at 18,000 revolutions per minute for up to 15 continuous hours. For reference, A 1 nanometer motor is over 80,000 times smaller than the width of a single human hair. These are machines at the absolute boundary of what physics allows. They exist at the scale of atoms themselves, and they represent perhaps the most remarkable frontier in the entire history of engineering. From a machine that weighs 31 million pounds and takes 3 weeks to travel 80 miles, to a machine made of a single atom that you could never see, touch, or feel, this is the full spectrum of what human ingenuity has created. One thing is certain, we are nowhere near done.